Bismillahirrahmanirrahim. So we are going to be talking about, we have already talked about acids and their reactions, their properties, physical and chemical. We are going to be talking about bases and alkalis, right? Let's get into a formal definition. What is a base? What is base actually? It is a substance that reacts with an acid to give a salt and water only. General equation that really comes about of bases for this reaction is base plus acid, which we have already done. Salt plus water. Now, what are bases? Bases, example of bases are any metal oxide, number one, number two, or metal hydroxide. All of them are called bases. Right? An example of this reaction generally can be, say, copper oxide, CuO plus, which is a base, right? Solid. H2SO4. Obviously, all the acids are always aqueous, which is going to give you a copper sulfate. It's going to give you a copper sulfate solution plus water H2O. This is liquid, right? I want you to analyze if we are going to make an ionic equation for this reaction. We are going to see that the ionic equation for this reaction is going to be copper oxide plus 2 H positive ions are going to give you copper 2 plus ions plus H2O, right? Similarly, if you consider another base reaction, this was a base, right? If we consider another base reaction, let's take sodium hydroxide, with sodium hydroxide with HNO3 dilute nitric acid. You're going to get sodium nitrate, NaNO3 plus water H2O, right? If you would want to make, now this is very important. This is an alkali, right? So this is going to be aqueous because soluble and liquid. Basically, the ionic equation for this reaction is going to be OH negative ion plus H positive ion plus H2O liquid. Basically, when we have this ionic equation, this is called a neutralization reaction. You understand? In most of them, we'll find that the neutralization reaction, this is what we said, right? Bases are substances that react with. So for every neutralization reaction, the ionic equation is going to be like that. Is this clear? Do you have any queries? Are you writing?
Yeah.
All right, all right. All right. So for every neutralization reaction, you're going to find that it has this ionic equation. This ionic equation tells us, ionic equation of as such tells us whether it is a neutralization reaction perfectly or not. All right. Let's move on. We have been able to discuss something that was we discussed that preliminary, but inshallah we'll discuss it again. When we talk about bases, bases are of two types again. They are insoluble bases and there are soluble bases. Right? Insoluble bases are still called bases or base, a singular bases, and the soluble ones are no more called bases, they are called alkali. All right. So what this brings us to an understanding what is going to be an alkali. So alkalis, they you can a special class of base. You can say this is a special class of bases. Right? So alkali is a base that is soluble in water. It is a base that is soluble in water. An example could be sodium oxide. Sodium oxide is a base because it is an oxide, N2O. Right? The solid, when it is dissolved in water, H2O, it is going to give you sodium hydroxide, aqueous, and is a base. The many generally there are more bases that you're going to find in your more alkalis that you like. Some common alkalis that you're going to come across in your assessments is going to be sodium hydroxide, potassium hydroxide, calcium hydroxide. So this gives you an idea that they're all of these bases, or calcium oxide, barium oxide, all of them are going to be what alkalis. They are soluble. And another out of the general trend is ammonia. This is also an alkali. Right? This is also an alkali. Another understanding that I think you should also have for alkalis, which is generally not really discussed in the course and elsewhere, but it is an idea that they do not give a definition for. They do not really say this, but it is what it is. So alkalis can also be called substances that dissociate to give hydroxide ion in an aqueous solution. All right. Alkalis are also, you're going to see this in A levels, inshallah, that they are also referred to as, they are also explained and defined in this manner. All right. But at the moment, we'll stick to the definition and understanding that we have already discussed. All right. On the other hand, if you look at copper oxide, if you look at copper oxide, it does its reaction with water. We do not find any reaction with water. It does not reacts with water. This means that copper oxide is a base and not an alkali, right? Let me know when you have written this.
Okay.
From here, we'll move on to discuss alkalis in greater detail. We would want to discuss their physical and chemical properties and their reactions. All right. So, when we talk about alkalis, let's talk about their physical properties. Physical properties. Alkalis have a bitter taste. Bitter taste. Secondly, alkalis can turn red litmus blue. Number three, alkalis can, or not really can, produce actually, produce hydroxide ion. Hydroxide ion. This is the hydroxide ion. Hydroxide ion, when dissolved in water. All right. Now, let's move on to chemical. An example could be like uh, if you have sodium hydroxide aqueous. What does this aqueous actually already means? That it is in this form in a solution, right? If the water is evaporated, they are going to come together. Why? Because this is an ionic compound, right? This is an ionic compound. It is going to form lattice. Generally, it becomes powder when you evaporate, right? Ionic compound. Ionic compounds like also acids, alkalis can also conduct electricity, right? They can conduct electricity in aqueous form, right? Because they are ionic compounds, metal and non-metal, right?
All right.
Similarly, if you're going to when you dissolve NH3 in water H2O, basically what happens is that you generally we have uh, ammonium ion plus OH negative ion. The water that reacted with hydrogen H2O, basically one of the hydrogen breaks up and attaches to ammonia like this one. So from 3 it has become 4 and it has gained a charge because one extra proton attached to it. Who are we calling proton? This hydrogen atom, because it only has one proton in it. So it gets attached to ammonia and this OH in the OH because water is like this, right? So this H gets attached to ammonia and the rest of this becomes an ion like this. You get it?
Yeah.
All right, let's move on to the chemical properties. When we are talking about chemical properties, actually we are going to be doing two reactions. There are going to be two reactions: bases versus, or alkalis versus acids, and the other one is going to be bases versus ammonium salts. These are the two reactions generally that we are going to be doing. And another one, sorry, alkali and a salt. Alkali plus or versus salt. These are basically three reactions that we are going to be studying in the chemical properties. First one is very simple. Number one, we say all alkalis react with acids to form a salt and water only. Salt and water only. To keep this in mind, this is called neutralization reaction. This is called in neutralization, salt plus water only, no other, no matter whatever is reacting, if there is anything else, hydrogen or anything else, it is not going to be called a neutralization reaction. And one of the biggest uh, uh, markers that the reaction is a neutralization reaction, that it will always have an ionic equation like this. The ionic equation of a neutralization reaction is always like this. All right, for any neutralization reaction. And you have to keep in mind, not all bases. An exception, I would want to share an exception here. Look at this. We have manganese oxide that reacts with HCl to give manganese chloride, manganese 5 oxide. Yeah, manganese, this is called manganese 5 oxide, right? And manganese chloride plus H2O plus Cl2 gas. Are we going to consider this as a neutralization reaction? No. Why? Can you tell? Because we can see this chlorine is another product that is being formed. And simple manganese oxide, this is manganese 5 oxide. Manganese 5 oxide. Right? Simple manganese oxide, which is like this, MnO, reacts with HCl to give MnCl2 plus H2O. Even though both of them are bases, right? All the oxide, metal oxides, all metal oxides are bases, right? Even though this is a base, right? Solid, solid. But still, a base is still reacting with dilute hydrochloric acid was not able, aqueous dilute hydrochloric acid was not able to give, was not called a neutralization reaction. This is what I want to point out over here. Similarly, the manganese oxide, an element, a compound of the same element, when it reacts with acid, it gives you a salt which is aqueous and liquid, and this is a perfect neutralization reaction. And if you would want to calculate the ionic equation for this, if you would want to know the ionic equation for this, it's always going to be H. Is this clear? So this is an exception. This one, not the other one. This one is an exception to the rule. But this is what we have already expected. All the bases are alkaline in nature. I mean, all bases, they react with acid to give salt and water. But in reality, not all of them. There are a few exceptions, but most of them, right? You have to keep this in mind. Most of the bases are insoluble. Most of the bases are insoluble. Just write it somewhere. I just forgot it. Need to write it somewhere. Most of the bases are insoluble. Is this clear? So this reaction is not a neutralization reaction, right? Not a neutralization. Not a neutralization reaction. Moving on to the next reaction. Second reaction is ammonium salt. The reaction of bases and ammonium salts. So basically, alkalis heated with ammonium salts. We have already understood a little bit what salts are. Sulfates, right? Sulfates is sodium sulfate, carbonates, chlorides, nitrates, all of them are salts. So any ammonium salt, let's like ammonium sulfate, ammonium nitrate, right? Ammonium nitrate or ammonium carbonate, ammonium sulfate, ammonium chloride, ammonium chloride, all of these are different salts. All the chlorides, phosphates, nitrates, they're salts. So ammonium ion is what? Ammonium ion is like this, NH4 plus. All right. Though this bond is a covalent bond, but it has some properties of ionic compound. All right. This is the ammonium ion. Ammonium ion. And what type of ion it is? It is a cation. It is a positive charge. So alkalis heated with ammonium salts give off ammonia gas. The general equation is alkali plus ammonium. You have to keep in mind alkali is heated. So you should write alkali over here. The reaction that we are studying are all for alkalis, all right? Keep that in mind. All the previous reactions, they are for alkalis. All alkalis, chemical properties of alkalis. Basically, this is alkali, do you understand? Properties of alkalis, right? So alkalis, when they react with, the general equation that we have for this reaction is alkali plus ammonium salt is going to give you the salt plus ammonia plus water salt, ammonia, and water. All right. An example can be calcium hydroxide, obviously aqueous, plus hydroxide already means that it is aqueous, plus 2N. So this is ammonium chloride. Ammonium chloride going to give you CaCl2, calcium chloride, plus water, plus NH3. So 2H2O, 2 calcium stays like that, 2, right? This is the equation. See? This is the ammonium gas, that ammonia gas. This goes for all alkalis, or whenever the alkalis are reacted with with ammonium chloride, you're always going to get a salt, water, ammonia gas, right? How do we do? How do you check if you have this tube and you have fumes that you're going to be coming out? You have to place a red litmus paper on the mouth or at the mouth of the tube. This red litmus will turn into blue. Is this clear? What is the ionic equation that generally forms here? Is this plus plus.
Okay.
Are you following?
What?
Sorry.
Learn.
The last reaction for alkalis, the third and the last reaction, alkalis react with, they can react with a solution of 1 metal salt to give hydroxide and another metal salt and another metal salt. I'll explain it to you. Don't worry. Just write the definition at the moment. It's what it is. Alkali plus, let's say, salt of metal A. Salt of metal A. Salt of metal A reacts. It forms a metal hydroxide as mentioned, and salt of metal B. Metal B. How? I'll explain. The metal hydroxide appears as a precipitate if it is insoluble. The metal hydroxide appears as PPT. Very important information. Paper is going to be full of that. PPT if it is insoluble. If insoluble, all right. Let's take an example. We have NaOH, sodium hydroxide, one of the strongest of alkalis. Plus, we have iron sulfate, FeSO4, aqueous, was is going to give us FeOH, solid, plus Na2SO4, aqueous. Do you understand? The metal hydroxide appears, the what happens, alkali can react with a solution of one metal salt to give hydroxide of another metal salt, right? So in the beginning the reaction was what? It was the sodium hydroxide. So once the reaction proceeded, it became it was iron hydroxide, sorry, sodium hydroxide. When the reaction proceeded, they switched their salt characteristics. You understand?
Yeah.
All right. The next and important point that you're going to have a lot of MCQs around, which or 2 markers, 3 markers generally, uses of bases and alkalis. Uses of bases and alkalis. The uses of bases, some bases like ammonium solutions, ammonia. Ammonia is an alkali. Some uses of window cleaning, cleaning in fertilizer, cleaning, fertilizers. Then we have calcium oxide. Calcium oxide is used in neutralizing acidic soil. Neutralizing acidic soil and concrete and cement, making concrete and cement. calcium oxide, right? And we have magnesium hydroxide, a very common one. MgOH2. Many uses in toothpaste, to neutralize acidity in teeth, on teeth, sorry, on teeth. Acid or acidity or acid on teeth. One of the most important uses, used as an antacid and antacid. Antacid to relieve digestion. Okay, and also acidity, because this is magnesium hydroxide is edible alkali. All right, it also helps reduce the acidity of stomach. When stomach becomes too acidic, we take such medicines like domperidone, Ryzec, omeprazole, or of those esomeprazole. All of them, they have this magnesium hydroxide that neutralizes the acidity, relieves the indigestion. And one of the most common ones, sodium hydroxide. Sodium hydroxide in making soaps, and cleaning detergents. Right? Because of their acidic property, sorry, because of their alkaline property, what is the basic property? They All of these characteristics are because of their ability as alkalis. All right. Any queries?